All right. All right, let's see what you guys came up with for factoring out our GCF here. So this person said the greatest common factor is 10 comma x, and we got 10x on the outside and then 7 minus 4x to the third power on the inside. This person rewrote it as 5 times 14 and 5 times 8. And then they realized, oh, there's a 5 in common. They pulled that out. So this is a correct step in the right way. But if you look at what's still left here, there's some more commonality between these two terms that we can also factor out. So this is not wrong, it's just incomplete. This person wrote this out as 7 times 10 times x minus 4 times 10 times all those x's, 4 of them. And then they underlined where they had commonality, 10 and 10, x, and I think this should be just 1x because they have to have it in common. And then they factored it out to get this. Divide everything by 10. So 7x minus 4x to the fourth power. This is another one where it's not wrong, it's just incomplete. So the GCF is 10x, yes. 10x, 7 minus 4x to the third power. This is correct. X is 10. So we're not solving for x. Here we did some factor trees, figured out that, hey, 5 times 2 times 7 and 5 times 2 times 2 times 2, they both have a 2 in common. Maybe, yes, but they also have a 5, right? So here we have the 2 that they have in common being factored out. Again, one of those ones that's not incorrect, it's just incomplete. So your greatest common factor is not just a common factor, but the greatest common factor you can get to. So, you know, if you write out the factorization of each term, 70x is 2 times 5 times 7 times x. And then if you write out 40x to the fourth, 2 times 2 times 2 times 5 times x times x times x times x. If you do this and then you go back through and you use like a highlighter or you circle, like if you're doing this on paper or a whiteboard is fine. I know it's a little bit tough on the Pear Dex, but you know, if I go through right now and just look for what's the same between them, well, there's a 2 here and a 2 here. All right, so that's a common factor, but I'm not at the greatest common factor yet because there's also a 5 and a 5. Again, that's a common factor. 10 is the same for both of them, but there's still more. There's an x and an x. Okay, now that I've exhausted all the options, now I can, you know, with confidence say that my GCF is 2 times 5 times x, which is equal to 10x. And some of you guys got that, some of you didn't, it's okay. When you write out the factored form, you're going to write the GCF on the outside, 10x. Then on the inside, because I started with 2 terms, once I factor something out, I'm going to have 2 terms left in the parentheses. And it's just what's left over, basically. So, you know, an option might be used a different color to see what's left. There's a 7 left for the first term. And over here I have 2 2s and 3 x's left. So if I wanted to write that out, I would have 7 minus 4x to the third power. It's kind of a terrible 3. And you can always check your work by distributing. 10x times 7 would give me 70x. 10x times 4x to the third power. 10 times 4 is 40. X times x to the third power is x to the fourth. We have that subtraction sign in the middle. So this is the factored form that you want. Some of you guys got it. Some of you guys were on the right path, okay? Just make sure that you're taking out not just a common factor, but the greatest common factor. And it can have numbers and it can have variables. All right, so today's lesson, it's a separate paradox than we had yesterday. It's on factoring by grouping. And your learning goal is that you can factor a polynomial by grouping. And so what I was kind of showing you here, this flow chart, the only time we would try factoring by grouping, come back to it, is right here when we have a 4-term polynomial. So the ones we're going to look at today come from a 4-term polynomial. And if we want to define what that is, it's a method of factoring when you're given a 4-term polynomial with no common factor. It's also called factoring in pairs because you take these 4 terms and you group them into 2 pairs of 2. Won't always work, but sometimes it does. And you can even try rearranging the terms to see if you can get it to work by grouping. All the problems we're going to work on today are going to work by grouping because I'm trying to teach you a method. So it will work. And these are the steps basically. So if you have a polynomial with 4 things being added together, 4 terms, check for that GCF. If there's a GCF, you do want to divide it out. If there's no GCF, then you can try factoring by grouping. So there's 3 steps. First step, you group. You put the first 2 terms in parentheses. You put the second 2 terms in parentheses. Second step, you factor out the GCF from each of these separate binomials. So now you're taking something that had 4 terms and you're splitting it into like 2 separate problems. You're looking at the first 2 terms together to find a GCF, and you're looking at the last 2 terms together to find GCF. And then once you do that, you're going to see that there's going to be a common binomial that you can factor out. So you can factor out a single term, but you can also factor out a 2-term binomial. All right. We're going to look at how to do this, but we're going to kind of start with this last step here. You know, what does it mean to factor out a common binomial? That's what I want to show you first. So this is an example of doing that when steps 1 and 2 are already done. We're just going to look for a common binomial. So this first example to the left is actually a 2-term binomial because there's, let me kind of just use some color here. So here is 1 term. Here's the second term. Okay, because terms are things that are added together. So this is just 2 terms right now. This is a binomial. And so we're looking for common factors. We're looking for a GCF, and that's what I'm trying to figure out. Is there a GCF? And I can use the highlighter to go through and see that in this first, you can't even see that. There we go. In this first example, 2x plus 7, that whole binomial shows up here as a factor. It also shows up here. So that is my GCF in this case. (2x plus 7). Okay, and so like we were before, it's the same basic idea. I'm going to then be able to write my factored form with the GCF on the outside. This is a binomial 2x plus 7. And then what's left over, well, I started with 2 terms, so I'm going to have 2 terms left in the second factor. And it's what's left over. So I can use a different color highlighter, and I can see that, hey, there's an x left here, there's a 3 here, and I'm subtracting them. So that's what's going in the second binomial, x minus 3. Okay, and then that's factored. So again, we're going to do another one. This is a binomial. You know you are done factoring when all you're left with is stuff being multiplied together and there's no common factor left inside that you can factor out. So you should always check that you didn't like forget about some common factor, but there's none left here. So the 2x plus 7, this was the common factor that they both had. So the GCF is this thing in yellow. And so the GCF is written first, and then what's left over is here. You're going to see the same thing happen with this other example too. Okay, it's just a two-term binomial because even though there's addition here and here, this is part of a factor that's being multiplied with 2x. So overall, the terms, this is one term. It's just being all multiplied together. It's one term. This is another term. And of these two terms, what is the same with both of them? X plus 6 and x plus 6. That's what's the same. So our GCF is x plus 6. And so we're going to write it as a factored expression with the GCF on the outside of x plus 6 because it's coming from both of them, so I only write it one time. And then in the parentheses, I'm going to have some stuff added together, two things specifically because I started with a binomial. So what's left over? You see there's 2x left here. I have a plus sign. I don't see anything here. So yesterday when that happened, when we factored out everything, we had to put a 1 there in its place, right? And so I can do that. I can think about just multiplying by a factor of 1 anytime I'm missing something. And now I have a complete binomial to put in this parenthesis here, 2x plus 1. Okay, so the next slide we're going to go to, we're going to look at, examples now where we need to do steps 1, 2, and 3. Because I was just showing you the last step. Okay, this is just the last step right here that you would do when you're factoring. So here's an example. It's totally worked out of factoring by grouping. You're starting with this polynomial here, x cubed minus 2x squared plus 5x minus 10. This polynomial has 1, 2, 3, 4 terms. If you look at each term, there's no common factor amongst all 4 terms. So you try factoring by grouping. So you group the first 2 together with parentheses, first 2 terms together to make this binomial. And then you come over here and group these 2 together with parentheses. And now you're looking at each of these as a separate problem. So for x to the 3rd power minus 2x squared, these both have an x in common and another x in common. There's 2 x's here I could factor out and 2 x's here. So that is the GCF of this smaller binomial, x squared. And then what's left over is x minus 2. So you're able to factor this binomial on its own. And then you look at this second binomial you created, 5x minus 10. The greatest common factor between these two terms is 5. So 5 gets factored out. You're left with x minus 2. And so they're using color coding here to show you that now this term and this term both have a common factor of that red x minus 2. So that's now the GCF of this entire binomial. And that x minus 2 gets factored out. And what you're left with is what's in blue. X squared plus 5. And this is totally factored. So we're going to try that with this example here. This is a polynomial. It has 1, 2, 3, 4 terms. I look for a GCF. There's no one thing that all 4 of these have in common. So I'm going to try factoring by grouping. So first thing I want to do is group the first 2 terms together and the second 2 terms together. I'm going to do that just with drawing in parentheses. I'm really terrible at drawing in parentheses, but I'll try. Or at least kind of funky looking. Okay, so that was the first step there. Just group them, step 1. Step 2 is to look at each of these separately and try to find a common factor that they have. X cubed and 9x squared. So when you're doing this, maybe you want to type it out. Maybe you can just see it. I'm going to type it out because I don't know if that is something that you can do yet. But I'm just going to write x cubed minus 9x squared totally expanded. So x times x minus 9 is the same as 3 times 3 times x squared. So times x times x. I'm going to go back and add my parentheses in a second. For the second binomial, x minus 9, that is already expanded for the x term because it's just an x. 9 I could expand as 3 times 3. Oops. Yeah. So anyhow, let me put my parentheses back so we can still see this grouping that's going on. So we have this binomial and this binomial. So I want to know, is there a GCF of these here? And I can see there probably is, yeah, because look, here's an x. Here's an x. Here's an x. Here's an x. So just these 2 terms have a GCF of x squared, or x times x. And so this is the second step. We're looking for individual GCFs of just the 2 binomials. And I'm going to probably use a different color for this one here. So, but I don't have anything. Sometimes you won't have anything in one of them. Sometimes you will. X, 3 times 3. There's nothing in common here. So there is no greatest common factor besides 1. And so I won't even divide that out, or I could write it. Maybe that'll help you see where it comes from. Anytime you can't find a greatest common factor, it's 1. That would be your greatest common factor. So the GCF here, I don't see anything, it's just 1. And I can write that in now as something that I'm going to divide out. So this is being multiplied by 1. So this one, we're going to rewrite a little bit differently. So I'm going to pull out this GCF of x squared. And then in the parentheses, what I'm left with is this x, this minus 3 times 3, which is 9. Okay, we have plus. I wasn't able to change this, so I'm going to put it back as x minus 9. And this is being multiplied by 1. So this is still part of step 2. Step 3 now is to factor out this binomial that is a common factor. So let's just call this step 3. No, I was going to try to change the color, but step 3. So we can see that x minus 9 shows up in both. So that's going to be on the outside. That's the first term. And then what's left over is x squared plus 1. So you guys see where that came from? X minus 9 was what I factored out. It's right here. Then the things that were left over. And so this is our answer. Now, if you wanted to check your work, you can multiply this out using something called the FOIL method. I'm not really sure if you guys learned that in algebra or if we were already like out. So I'm going to show you how to do that real quick with this problem. It's called FOIL because it's an acronym that tells you what 4 things to multiply together. So you would multiply the first terms, you would multiply the outside terms, then multiply the inside terms, and then the last terms. That would give you a 4-term polynomial. So if I just look at the first terms, x and x squared. If I look at the outside terms, that would be x and 1. If I look at the inside terms, that gives me negative 9 times x squared. If I look at the last terms, that's negative 9 times 1. And these are being added together. Okay, so these would be the 4 terms of your polynomial after you multiply. And so basically, is this the same thing we started with? You can simplify it to c. So like x times x to the second power is really just x cubed plus 1 times x is just x. They're using minus, so minus 9 x squared minus 9. And so it's in a little bit of a different order. Like the middle 2 terms are in a different order, but it's the same polynomial we started with, so we did check our work and it does work out, and this is actually the answer. All right, you guys have questions about that? X squared. Did I make a mistake? Maybe I did. No. Okay. So you see where it comes from though? This x squared here goes right there. All right, so when you guys are ready, you're going to go to the last slide. And you have 2 problems to do here. So let me show you that without closing my work here so you can still see that. Okay, so when you're ready, you're going to go to this slide. It's being weird. So you do want to check for a GCF when you factor by grouping. Example 4 does not have a GCF. X cubed, 7x squared, 5x, 35. These 4 terms all together, there's nothing they all have in common, because these first 3 terms, they all have some sort of an x. This last one doesn't have an x. The first term doesn't even have a coefficient besides 1. So the GCF right now is just 1. But for your second one, this one does have a GCF. Can you tell what it is? What do these 4 terms all have in common? It's a number. They all have a certain factor that is a number in common. I could divide out a certain number from all 4 terms. Can you see it? Ah, didn't see it on here. My vacuum comes in handy when there's a mosquito by my head. Vacuumed it up. Yes, Vanessa, you are correct. It is 3. Okay, so this 4-term polynomial right now has a GCF of 3 that we want to factor out to start with. Because if we don't factor it out right now, we're going to have to factor it out later. So if you always check for your GCF first and factor that out first, it makes the numbers that you're working with smaller. If it's possible to make them smaller, it's always better because it's just easier to do math with smaller numbers typically. So for this one, there is a GCF. Three. Which means we're going to have a 3 out here. I'm going to do it quickly. This is going to tag along this whole problem. And so then we put in brackets what's left over. If I divide 3 out of 3, x cubed, I'm left with x to the 3rd power. If I divide 3 out of 12, I'm left with 4x squared. If I divide 3 out of 6x, I'm left with 2x. And if I divide 3 out of negative 24, I'm left with -8 or -8. Okay, so now when you go to do your grouping, this is what you're grouping. And you're looking for a GCF of each of these individually. So is there a GCF here? I'm going to try typing that. With this one, you can jump right into factoring. Seven. All right, so you guys are working on the practice on your own slide right now, and I'll give you feedback through the Pear Deck. I'll try to help you if you have any questions too, if you ask me through GoGuardian or in the chat. But if you don't have any questions and you think you got it, you want to leave the meet, you can. Leave that up to you. Example 4, yes. So I will do some more in example 4. Let me at least, write out these factors so you can help you see how you can find the GCF. So I'm just going to expand it as much as I can. X cubed is just x times x times x. And then we're adding to that 7x squared. 7 is a prime number, so it's 7 times x. I'll go back and add in my parentheses in a second. For the second two terms, 5 times x, 5 is prime, so 5 times x, plus 35. 35 comes from 5 times 7, which are both prime numbers. Looking at these two together and these two together. And if you want to use like a highlighter tool or something to figure out, hey, what do they have in common? They have to both have it. So like if I look at this one here, the first binomial, they both have an x in common. They both have another x in common, but that's it. There's nothing else that they both have in common. So this GCF right here is just x times x or x squared. for the second binomial, what do these both have in common? What's the GCF of the second binomial? What do they both have? It's a number. They both have the same number as a factor. This term and this term. Yes, 5. 5 and 5. So my GCF here is 5. I have two separate GCFs. I'm going to factor this binomial. I'm going to factor out x squared. And for this binomial, I'm going to factor out 5. And what's going to be left is the same remaining terms. Let's leave it like this. Okay, so if you factor out the GCF of x squared, what's left over? If you factor out the GCF of 5, what's left over? Okay, Veronica. Okay, so Veronica, you got example 4 correct. So the way you wrote example 7, so the 3 that we're factoring out, it's of the entire thing. So it's almost like I just put it out here and kind of just let it tag along, and it'll just be in my answer at the end. You just want to focus on what's in these 2 black brackets, which is this binomial and this binomial. This has a different GCF. The GCF here that they both have in common is 2 copies of x. The GCF here that they both have in common is 2. I could probably do this in a different color, green. Make it match the other one. Okay, so if you're using this as an example to get through this, that should help. All right, I can set this one up the same way as this one's set up. But we have like 2 minutes, by the way. So those of you that are in here, you want to grab sanitizing wipes and kind of wipe down your area. We will keep doing this. We have the 3 on the outside. And then we have brackets. And then we have this x squared. Then we have a parenthesis, another parenthesis, and inside, what are we subtracting? When we factor out x squared, what's left over? Plus, GCF here is 2, so that goes on the outside. We have parentheses, and we are subtracting something inside after I factor 2 out of both of these terms. And this 3 just keeps tagging along until you get to the end. Have a great day, guys. Hi, Jackson. Bye, Fernando. Veronica, where did 2x minus 8 come from? 6x divided by 3 is 2x. 24 divided by 3 is 8. And I factored out a 3 from all 4 terms. These all were divided out by 3. Okay. All right, you guys, you have a good rest of your day. The video will be up of this by the end of the day, okay? You can go back and rewatch it if you need to. See you later.